here is a airplane on a string. Does that look like an airplane? Draw a better air. Oh, why do I always put it so high? Draw it
I thought
again.
his arm was super long.
It is. That's a string.
He's the kid from the Little Mom from The Incredibles.
Oh yeah, I
That's
know
the
that.
person.
That's the girl in Dash. And what's the other one?
All right, here's an airplane.
I want to be her.
It looks like a cross. The airplane is zinging around in a circle. Draw a picture of it. Because there's circular motion, we know that centripetal force is at work among us. So centripetal force is causing all circular motion, so it's causing, that's an airplane.
That was kind.
This is a guy, where's my string? All right, I'll act this out. Here is the airplane right here, so he's going like that. All right, so we know if there's circular motion, centripetal force is at work. But what is causing the centripetal? Look at the snow.
You wanted to look at you, but you
Look, but one eye over there, one eye over here.
All right.
All right, this one, the centripetal force is at play. But what is causing the centripetal force in this case? You know the answer. See if you can figure it out. You can brainstorm. What is causing it? What force that we've learned about? On your test, you wrote down examples of force. What?
Friction.
This is not friction. That was a good one.
Air resistance.
force.
Do you see any friction at play here? No.
Tension, torque.
Tension. And the tension, the thing that is causing the friction, the force, is called tension. So, goodbye.
Good job, Morgan.
All right.
It's like London Tiffany. Yay!
So back, yeah. Oh, that looks more like rain and snow, but I guess that's
Yeah,
a
it was
problem.
freezing rain just in here.
When you were coming in.
Yeah.
That's worse than snow. What causes centripetal force? One of them is Aaron and Fuji Bob. Brendan, would you keep quiet? Tension. Fuji Bob and Aaron. Tension is one thing that causes centripetal force. So let's do a problem with that. Then we'll add to our list. So I'll come back to you. All right. Let's draw the guy with the airplane. Maybe I'll fit it on here. Thank you. Happy she gets her exercise in this class. All
I
right.
ran a mile randomly yesterday on the treadmill.
That's cool. Here's an airplane, and it's being
True.
flung around in a circle. The airplane. Here's the person who's fleeing it with the long arm. All right.
Very small body.
The airplane is a fairly large toy, 1.2 kilograms, and we know the tension in the string. The tension is 54.1 newtons. So I want you to find the velocity of the airplane. So sketch this problem in your notes. You got somebody flinging the airplane around. The string is 0.34 meters long. It's 1.2 kilograms is the mass of the airplane. And the tension in the string is 54 point, what did I say? 54 point what?
Is that the is that the force?
54.1.
Is that the force? The
It
tension?
is. The tension, which you just told us was force centripetal. So I pull out the equation. Force centripetal equals mv squared over r. And you plug in the numbers. And Morgan just said, is the tension force centripetal? It is. So we're not trying to find force centripetal, we're trying to find V. So V is right there.
So you have to move
I don't know if I have a snow scraper. I come out of a garage normally, so.
Do you have to
Yeah, we
do
usually have a scraper.
.012
Alright.
for the kilograms?
Yeah, it's already 1.2, it's already kilograms. So we're gonna put in some numbers.
Okay, cool.
Force centripetal is 54.1, because the tension is providing the force centripetal. So I'm gonna use that number for force centripetal. Mass remains 1.2. Velocity is what I'm looking for, and R is 0.34. All right, explain mathematically, Molly, what do you do with this equation to get it, I can't move this, can I? How do I solve for B? What's the first step?
Multiply both sides.
Multiply
by 0.34.
both sides by 0.34, then
Divide by point.
divide by
1.2.
1.2, and then
Take the square root.
square root. All right, this is getting old.
3.9 is what I got.
3.9. Going once, going twice. 3.9. And what kind of units would that be, Morgan?
Meters per second?
Meters per second. Anyone confirm?
I confirm.
Aaron, you said yes? Okay.
I confirm.
Okay. Looks like it's here to stay. That's the one we just did. All right. All right, let's try to finish up. I have one more example to show you, and I need that transparency that had I always lose them.
Was
in
that the
middle.
answer to number 2? The second will cause the centripetal force.
Yeah, I'm looking for that one. Oh, here it is. Thank you.
You're welcome.
All right. Tension is not the only thing that creates centripetal force. So we're going to look at something else that's going in a circle and see what that is. It's not going to be tension this time. So this time I'm going to take an object, and I have to draw it on here again. This time we'll have a little car, smart car, or a bike or anything, and
Actually, that looks like glasses.
I actually kind of like the problem.
my smart car. You get more and more less like a car.
Goggles, headphones, beats, anything.
Oh yeah, it looks like there's eyes inside of the goggles.
Oh,
Like the
no,
little
look at
dots.
you.
All right, guys, we're taping this. All right.
Oh yeah, do we need that timer?
Yeah, did you time it?
I've been timing.
Yeah, she's been stopping
She's on
and
top of
starting.
things.
Under the radar.
Yeah, she's good. All right. So we have a car going in a circle. Anytime there's circular motion, force centripetal is at play. So what is causing centripetal force this time? Is there a string hooked to this car? When you go around, what do you call those, clover leaves? There's no strings zinging you across that circle. So what force is it this time? I need to know.
Speed.
Pardon?
Acceleration.
Acceleration is not a force. We're looking for a force. What force causes centripetal force in the car going around the circle? Think of all the forces you know.
Velocity.
Velocity is not a force. Torque, we decided, we tweaked that, it's not a force
Is it
either.
gravity?
Gravity, that would probably be my answer, but it's not. Gravity's pulling the car down, but it's not pushing it in a circle. There's one force that you haven't mentioned that you know of.